Hello, and welcome to this video on designing and editing GDS files. In this video, we'll be creating a macro with KLayout to calculate the area of objects in our layout. We'll be using the Qt library in KLayout to help us create a dialog box where we can enter a set of user-defined parameters to help us calculate this area. Let's jump right into the macro development window, and we're going to create a new macro using the Qt dialog sample for Python. We're going to rename this calc area for our area calculator. This current example here was for creating a screenshot using the Qt dialog window. We're going to modify this for our area calculator. The first thing we're going to do is call this area calculator, the name of the class in the file. There's two functions in this class, a button clicked function, which is going to do an action when we click a button, and our initialization function. Let's ignore the button click for now. We'll come back to it later. Let's set up this initialization first. So here we're setting up the parameters for our calculator. And specifically, we're creating the dialog box that we're going to use. It's going to have the various buttons that we want to push in it. The first thing we're entering is the title, the window title. That is like the macro development title you see on this window. It's the text that displays in that kind of top left corner. Let's just set that to area calculator. Next is the window size, 400 by 120. That sounds great. This next one, all of these functions that start with a Q are instances of the Qt dialog library, so they're all kind of related to that. The first thing we need to set up for that is the layout for the actual dialog window itself. This is kind of the holder that's going to hold all of the individual components that we want, the labels and inputs and things like that. So we're going to leave it on this default, the QV box layout. That sounds great. The only thing I'm going to do is change the variable name. I'm going to make it Qt layout. So this variable here is how we're going to reference this box later on, the kind of dialog box. When we want to insert something into it, we're going to reference this Qt layout variable that we just created. And next, we're going to kind of set the layout of this whole thing, of this class, to this Qt layout. So we're going to update this variable name here to Qt layout. We're using this box layout for our dialog box. Okay, the next thing we have here is a Q label. So again, this is a Qt item, and it's for a label. This is just a piece of text that the user can interact with. It's just kind of a display to tell them what to do or to kind of share a result. So right now it's saying press the button for a screenshot. We want to say press the button to calculate the area. So that's the display text in the quotes there, and we'll change the variable name to image, which doesn't really make sense in this case, to how about area. That sounds pretty good. And so then this next line here is where we're doing what I mentioned before. We're taking that Qt layout, our overall layout, and we're adding the widget that we just made. So we're adding this label, this thing that we've named self.area. That label is now getting added to the dialog box. So in the dialog box, the first thing we're going to have is this label that we just created that's saying press the button to calculate the area. If we're going to tell someone to press a button, we should probably have a button for them to press. So that's what's here is this button. We're setting that equal to a Q push button. So again, another Qt object. And the text that's going to be displayed on the button, it was originally screenshot. So let's again say calculate area. We're setting the font here to be a little bigger and bold. That's fine. We're not going to mess around with that. And then again, this last line of this little section is, again, adding that button to the Qt layout. So we're going to have the label first, the self.area, and then below that, we should see the button, this push button that we just created. And then lastly, this last line of the initialization function is saying button.clicked, call this self.buttonClick function. So this is handling what happens when a user clicks the button in our macro here. So that's going to be an actual function that's called when the button is clicked. We'll jump over to that in a second, but first, now that we have this all set up, let's run it and just make sure that it kind of looks like what we expect. So I've just saved it, and now I'm going to run script from the current tab. When I click that, oh, we missed at the bottom here. We need to update this as well. I should have mentioned this. So when we're we want to have this dialog display in kind of the main application window. So that's what this is doing. This application main window is where the dialog will display, and we just need to call the class itself, call an instance of it, area calculator, and then lastly show to actually make the dialog box appear. So we're kind of creating it, naming it dialog, and then asking it to show. Let's run this again, and there it is. So indeed, first thing we have here is the title, the area calculator at the top, then the label saying press the button to calculate the area, and lastly this big button that says calculate area. I'm not going to push it at this point because we haven't changed the button class, and right now it would take a screenshot just like it did before. So let's go ahead and close that. Let's go make that button do what we want to do, which is to calculate the area. So I'm going to scroll up here. Here's our button clicked function. Okay, so let's remove some stuff here. We don't need these if statements. We're not creating an image again. We're not creating a screenshot, so we can get rid of that. We'll leave this set text for right now. So then the first thing here is grabbing the view. So it's saying application instance main window current view. I mean, this is just essentially getting us down through the hierarchy of the application so that we get to the current view for this layout. So that's what you're looking at here in the window is the current view. You should kind of just remember this syntax here because it's just kind of a way that KLayout organizes these different set of functions. Next, from this view, we want to call the layout itself. So I'm going to define a layout, a variable layout. I'm going to set that equal to view.cellView0. This is looking at the current cell view, and then I'm going to call the layout here. Again, these are just a set of functions that KLayout uses to organize the different parts of the application. We want to get down to the layout because that's where the actual objects of our layout are going to be contained. Okay, the next thing we want to do is I'm going to set up a variable that I'm going to call total area, and that's going to be the area that we're going to calculate for each of our objects. So we'll have this variable total area. We'll set it to 0 initially. As we go through every object in our layout, we'll add the area of that object to this total area such that at the end we have the sum of all the different areas. So I mentioned that we're going to need to loop through everything in our layout. So the first thing we need to loop through is the cells. That's kind of the top of this organization of the layout. So we'll make a for loop here. So we'll say for cells in layout dot each cell. So what each cell does is it's a function that iterates through the cells in the layout and returns each one. So it's essentially to returning a list of the different cells in the layout. And at this point, just to kind of demonstrate what's going on, I'm going to just print cells so that you can see, maybe we'll say string of cells just to make sure it works properly. So you can see what each of these cells contains in the for loop. So if I run this and I click calculate area, image not found, that's all right. And we're going to change this to cells dot. So it didn't like this image down here at the bottom because we still have that image variable. We'll say self.area, and we'll ignore this for now. Let's actually just comment it out for now. And so string of cells returned in the bottom here. This is where it printed. It says it's returning a cell object. If I do cell.name, that should actually return the name of the cell. When we run this and push calculate area, it's saying top. So over here, I only have one cell, it's called top, and so you can see we've gone through the list of all the different cells. In this case, they're just one, and it's returning the cell object here, and the name of that cell is top. If we had more cells, it would iterate through each one of them, return us each cell, and then we could find the different layers and objects inside of each of those cells. That's good. The cell loop is kind of working. Next, we're going to do a for loop through the layers. So I'm going to call this for layer in layout dot layer infos. And again, let's print that just to see what was going on here. So I'm going to say layer dot string of layer. I think that's all we need to do in this case. We don't need to call the name. Let's run that, calculate. And so here you can see it's printed out the 3 layers here. So in this particular layout, I have layers 1, 2, 3. And it's printed out here 1, 2, 3, 1/0 because the data type is 0 for all of them. And so that's indeed pulling all the layers. That's really great. The next thing we want, now that we've got the cells, we've got the layers, we want to actually look through the objects. So here we're going to say for objects, this is kind of your shapes. So let's call it shapes. Shapes in cells dot each shape of the layer. And actually here, it's not the layer, it's the layer index. So let's make a new variable here. And let's call it layer index. And I'm going to set that to layout dot layer indexes. And so this, similar to layer infos looks through the layout, returns a list of all the different layer names. So layer 1, 2, 3, and the actual layers themselves. We could modify things with those. Layout.layer indexes goes through the layout and returns all of the indices for the layer. Those indices are what are used by cells.eachShape. So cells.eachShape says for every cell, go through and list me all the shapes in those cells on a particular layer designated by the layer index. So really this should be like layer index here. So I need a way to kind of map from my layers that I get from layer infos to my layer indices. So if I just get layer index here, let's say layer index is, and what I'm going to do here is, in addition, this is a Python thing, I'm going to spit out an index and a layer using the enumerate function. What enumerate does is, for a list like this, it's going to return indices for the list as well as the contents of the list. And to just see everything, let's comment out this one, just to really show you exactly what I'm doing here. So I'm going to print now, I'm going to print the layer name. So we'll see that just like we did before, 1, 2, 3. I'm going to print out the IDX, the index from enumerate, and then I'm also going to print out layer indexes of that particular IDX. If everything's done properly when we created the file, these things should all match. But in this particular case, so here they are down here. So again, we have the name 1/0, that's the first layer. The IDX is the next one, so that's just 0 in this case. It's the first index for that list. And then the layer index is 0. So those all match. The layer index and IDX match. But for the second one, layer 2, the IDX from the enumerate function is 1, but the layer index from the actual file is 2. So I kind of did a trick here. I purposely did something bad, is when I was creating the layers, I created an extra one and deleted it. So a layer with index 1 was actually created at some point but removed. So now the actual indices in the file are 0, 2, 3. To make sure that everything matches, because here layer index 1 and index 2 aren't the same, I'm going to make sure I use these real layout indices in this last column here when I'm using the each shape function. This is just a careful thing to kind of make sure that everything's done properly. And I just wanted to show you exactly what's going on here so that nothing's hidden and you can see how to kind of cover yourself a little more and make sure you're not missing indices if things have been modified on you. Okay, so to get back to it, so the next thing we're going to do here is this for loop for shapes in cells.eachShape. And what we're going to use is we're going to use the layer indexes of the IDX. It's the same thing we printed here in the last line, layer indexes of IDX. So that should be the real layer index for a particular layer. So when someone's looking at layer 1/0, they need real layer index 0. When they're looking at 2/0, they need index 2. And for each of these shapes, we're going to add the total area now. So let's say total area plus equals shapes dot d area. So that function d area gives us the area of that particular shape in microns. So it's going to grab the first shape in this cell on a particular layer, calculate its area, and add it to our total area. Going to go through all the different shapes, calculate their area, and add it to total area. So in the end, the total area will equal the sum of all the areas in our layout, which is exactly what we want. Now we've got total area set up. Let's return that in the dialog so that the user can see it. We don't want it printing out in this console field at the bottom because that might not be available to the user. We want it in that pop-up window because it's kind of nice and clean. Everything's in one place then. So let's change this set text here. Let's make it say total area. And I'm going to append to that a string of the total area. So I can't append the number total area directly, which is going to be an integer in this case, or maybe a floating point, depending on if our areas are contain floating point numbers. So converting it to a string will allow us to append it to this other string. You can only add a string to a string. You can't really add a number to a string. The different variable types won't necessarily add properly in this. So we want to make sure everything's the same type when we convert it into a string to then display it in this set text function. Okay, so now if we run this and click calculate area, we can see the total area is 21. Let's just clean up that make it a little nicer, let's add a colon here and a space and run that again. Now we get total area is 21. And so just to kind of confirm, let's look at our layout here where I made it very simply 3 different boxes, which are a micron on a side. The smallest one is a micron on a side. So 1 micron, then 2 by 2, which is 4 microns, and 4 by 4, which is 16. So 16 plus 4 plus 1 is 21. So our script, our macro is indeed working correctly, which is great. So the one thing that we haven't really done, or that we have done at this point, is add it across all the cells, all the layers, all the shapes. What we might want to do instead is to be more specific about which layers we're going to use. Let's say we only want to look at shapes in layers 2 and 3. How could we do that? Well, we could go in and change the code itself. We could say, don't loop through every single layer in layer infos, only loop through indices 2 and 3, and change that here. But that doesn't really let the user modify that. We should have a way for the user to change them from that pop-up window so they can select whatever they want. In order to do that, let's go back down to the initialization section here. Let's give ourselves another input. Let's make a, let's call it self.layer input. Let's make a new thing. Instead of a label or a button, let's make a queue. I believe it's a line edit. And we'll say, we're not going to have anything there to start, so just empty quotes, and we're assigning it to self. And then we'll go qt.layout, excuse me, dot add widget. So again, we're just adding this in just like we did the label and the button earlier. Okay, run that. Now we've got a text field here where we can have someone enter. And even better, let's add a label above that to let them know what they should enter there. We'll just copy this one. And let's call this one view label. We'll say this is layer label. And we'll say enter the, or how about select the layers. So now we have a dialog box, a text box, where we are prompting someone to enter the layers that they want to calculate the area for. So select the layers. We haven't added any logic behind that. We need to go back up to our button function and we can add some logic there. So let's say that we want someone to enter information there in the form of the kind of the layers in the bottom left here. So we want them to say explicitly, I want layer 1/0 or maybe 2/0 using that kind of syntax. Or maybe even we can have multiple layers, 1/0, 2/0, something like that. So first, let's get the text from that input. So let's say layer, I'll call it layer input again, is going to equal self.layer input, self-layer input dot text. That's going to grab whatever they entered, the user has entered into that. And next we're going to use the split function. So got the R here, layer input dot split. Split is a Python function that allows us to separate a string by some character or multiple characters. And so here, let's separate it by a comma. Let's assume someone's going to enter it of the form 1/0, comma space 2/0, or comma and who knows how many spaces. So if we split it by the comma, we'll get a list that contains 1/0 and then another item which is comma space 2/0. Next, let's remove those extra spaces. So I'm going to say layer input. I'm going to do some list comprehension here. We'll say j.strip. So strip is a function for strings that removes extra white space on the beginning or end of the function, or of the string, for j in layer input. This is going to go through each item in our list of inputs and remove any leading or trailing white space. And now we've got a string which should contain, or we should have an array here that contains 1/0 and the next element is 2/0 or whatever the user has input there. which is exactly what we want. And so now let's come down here and let's say, so we're going through in this for loop here, and we're pulling out the layers, LYR, from the layer infos. And we can say, for each one they pull out, if that LYR value equals or is in the layer input string list that we just created. So if when it's iterating through all the layers in our file, if the layer that it pulls up is in the list of ones that the user inputted, then let's do this thing where we add the shape or the area of the shapes to the total area. If the layer that it pulls up is not in that user-defined list, then we are going to skip it. So we just won't do anything. So we'll have this if here, and if it's not in that list, then we just ignore it. We don't add the total, the area to the total area. So let's see if that's working now. So now if I say 1/0 and calculate area, we've got a error here. Oh, because I'm just comparing the layer itself, which is a part of the layer info class, so I need to convert it to a string. And that way I can compare the string of layer to the actual strings in that input the user entered. Let's try it again and calculate area. And now it's saying total area 0, so we're still not getting something quite right here. Of course, I'm never actually saying, saying layer input equals the layer input that I split. I was doing the split and then never saving it, so it was never keeping that split that I did. Let's run this one more time. Calculate area, and now I see total area as 1.0, and everything here is making sense. So now if I do comma 2/0, it's giving me 5. So it's taking the 1 area from layer 1 and the area of 4 from layer 2 and adding them together to get total area of 5. This is great, exactly what we wanted here. My one complaint would be it's not so convenient to have to type in those layers every time, separate them by commas. If I wanted to do 10 of them, I'd have to enter a whole bunch of different things. What if we could do one more thing to make this even easier on ourselves? Instead of having this line edit here, let's create a new input. Let's again call it self.layer input. But instead, let's make it a queue list widget. Of self. And what I want to do is I want to make this list. This is essentially going to be let me actually just add some empty items to show you what it's going to do. So I will do self.layer input dot add items, and it will let me add a list of items here of strings, and then we'll just need to add that to the layout. Okay, let's run that and see what it looks like. So now you can see it's like a list here where we can select different items from the list. So this would be, if we can have that display all the layers in the layout, it'll make it much easier for someone to just select whichever ones they want to add. We need to add one more line here to make it able to select multiple items. Right now I can only select one or the other. So I'm going to say self.layer input. So this is just a function of this one where we can kind of set the selection mode. And then we're going to set that equal to PYA. This is just kind of a long string here that I got from the API for this particular object that lets you set the selection mode. And so we're going to set it to extended selection. Now if we run that again, we should be able to select more than one. Indeed, that's great. Okay, so now we've got that. The next thing we need to do is to actually pull in the layers from the layout in this part and add them to this list. Instead of A, and B, we want to pull the real layers. So again, I'm going to grab this from here. I'm going to put this here, and so we'll say, again, we're pulling the layout from the file. We're going to pull the layers from the layout. So This was just the same as before. So it's layout.layerInfos. And we're going to need to convert them to strings using list comprehension. So a string of j. Yeah, so again, layer infos returns a list of all the different layers. It's returning the actual layer info objects, and I want to convert those into strings. So I'm going to just call string of each of the items in that list using list comprehension here, and save that back to layers. We'll get just a string of like 1/0, 2/0, exactly as we want. And so then we can replace this list here, which we kind of put arbitrary things in, with our real layers from the layout. And if we run this, we can now get 1, 2, 3, exactly the layers that we had in the file. Great. The very last part of this, before we're all done, is to make sure we handle that input properly. So before we were getting the text from that input. Now what we're going to need to do is get the selected items from that. So we'll say layer input, self.layer input dot selected items. So that's going to be whatever we've selected in that little list there. And we're going to need to get the text of each of those. So again, another list comprehension here. And so here we're going to do j.text for j in layer input. So the text of each of those will be the values from each of the selected items, which will just be the layers. Let's comment out these 3 lines here. And then we should be good. Let's check if it works. So if I select layer 1, calculate, it's showing me an area of 1, 4. If I do all 3, I get an area of 21. So this is exactly what we want. A nice, easy way to select layers from this dropdown and calculate the total area in our layout of all the shapes in a particular layer or multiple layers using this nice dialog box. So this gives us a great way to interact and do this calculation. And I hope it's a useful example of how to use these Qt dialogs to interact with your layout.